Hi, and welcome to the Web Portal and Query Engine team's COSC 320 Information Technology Project presentation. For our project, we did the Web Portal and API for the Pollinator Monitoring Project. Our team consists of Raj, myself Thomas, and Brittany. In this presentation, we'll cover the project overview, the plan, the execution, the outcomes, the software, and project closure and handover. The primary aim of this project was to provide an application for farmers and others involved in growing horticultural crops that both instantly identified pollinators visiting their crop and also compiled data for researchers to better understand the relationships between crop species and different pollinator insects. Further down the track, it's hoped that a version of the application would be developed that is targeted more widely to anyone interested in identifying pollinator insects on any crops and flowers. The scope of our project was 3 parts. We were to create a web portal providing the primary interaction for the user base, being researchers and farmers and the general public, and within that portal to make available the data that the project received and basically presented in a way that was user-friendly and usable. And the second part of the project was a data store, so a location where all the information being uploaded from participants in the project was stored in a persistent state, and that was flexible and would also scale with the project. This component provides a key functionality for the entire project, and it needed to be robust and comprehensive. The third main part of the scope was the API, the Application Programming Interface. This would provide features so that the mobile app team could interact with the portal and data store to store, retrieve, and access user-related functionality. The project was broken into roles and responsibilities. Within our team, I took the role of database and web elements for the project. Raj took over web and API elements, and Britt took over the UI and the project management aspects of the project. Each member of the team shared the interaction responsibilities with the clients and other stakeholders for the project, and working in collaboration with the application team. During this project, our team followed the waterfall method, in which we held our initial meetings to scope out the requirements of the client. We performed our analysis on those to come up with our design. From our design, we began our implementation and coding. Throughout the implementation phase, we were performing our testing and verification, and leading into the maintenance stage, we began to examine how we would handle handover and the transition of the client between this team and the next team. I'll now hand over to Britt, who's going to cover the planning and execution sections.
The project was based around the 3 key actors involved. So this was the users, obviously, who will be actually utilising the web portal to identify the pollinators, the admin, including the researchers who are identifying the relationships between the pollinators and different crop species, and lastly the API, which is creating the connection between the web portal and the app, as well as other apps down the track. The final project delivered to the client included the source code for the software, the documentation for all components of the project, including the MIT licensing details, allowing the client to use the software free of charge, as well as the reports created throughout the project, recording all progress throughout the whole project. Despite the location differences between the members of the group, the communication was actually quite strong. Within our individual team, we mostly communicated using Slack, but email and Google Docs were also utilised throughout the try. Slack was also used to communicate with the app team, though that wasn't quite as successful as we'd hoped. Between the team and the client, weekly meetings were held over Skype to discuss progress and any ideas that either party may have for the development. The project followed the proposed schedule quite well, with each task being completed by the end of the trimester. There were a few adjustments due to scope creep that had to be evened out in other sections, but the task was delivered in the correct time with no major issues. As with most projects, there is risk involved, usually related to the additional requirements being added throughout the project. The scope creep became our biggest issue. having to change and add components into the plan each week after the meetings with the clients set us back a little bit. But on top of that, the regular risks involved with being a human being caused a few setbacks, so members falling ill and having availability issues related to work and home life and such caused a few issues. So the actual execution of the software. To begin with, the project was passed along by the previous group was found to be not of the standard that we thought was adequate for the client. The key features of the database weren't functioning properly, and the web portal was aesthetically displeasing and provided a poor user experience, to be honest. After deliberation, our group decided that we'd start the project from scratch in a way that we thought was better matched to the requirements of the client after speaking to them. After doing this, we also hit a few road bumps along the way, mostly to do with the user experience being compatible with the Earthwatch standards and following the level of professionalism shown by the iNaturalist site, which was found by the clients mid-project. So that gave us something to base it off, so a few changes had to be made there. And as said before, the communication with the app team wasn't overly ideal, and this left us with very little feedback on the API and data store requirements. This caused a bit of delay and meant that a few aspects of the code had to be rewritten once they clarified their needs to us. In relation to the previously mentioned risks, the scope creep and resulting requirements inflation gave the team the most issues. Starting straight away with the inadequate UI of the existing project we were handed, starting the project from stage 1 but also having to include all of the additional components we were asked to develop was quite challenging. To add to this, the extra requirements from the clients arose, and they became priority so that the project we produced was in alignment with what they actually wished for the software itself. But aside from these issues, the risks were tracked pretty well, and the team picked up the slack for each other where necessary, which resulted in the project running quite smoothly overall. In saying this, it doesn't necessarily mean that the whole project was smooth sailing. The database caused a few issues, especially after having to redesign the whole provided database, as there were normalization issues with the data model. And as said, a project where the individuals are in a different location is always going to be a bit harder than if we're able to meet and complete the project face to face and discuss with the clients in person. And lastly, managing the scope creep really was what made the project the most challenging, but adjustments were made to handle all of these challenges in a timely manner, and it turned out pretty okay. To start with these adjustments, the testing and delivery phase had to be cut a bit short because we needed the extra time to complete the rest of the project to a standard that we thought the client would be happy with. The documentation had to be fused with the development phase, otherwise the testing and delivery phase would have been far too full on with the shortened period of time we'd allotted. With this shortened time, the final 3 to 4 days of the testing and delivery phase were allocated to receiving feedback from the app team so that the finishing touches could be made and everything could be finished off to a good standard before the project's end. So I'll now hand over to Raj to cover the outcomes and project closure sections.
Thanks for that, Brittany. I'll be talking to you guys about the summary of what occurred in the project and what software was produced, followed by some demos of the web portal and the API functionality. So let's start with summary. When we inherited the project, there was a lot of technical debt in terms of the code base, the data store model, and the visual aspects of the site. That debt was addressed in this project by rebuilding the entire web portal, data store, and API using an MVC framework. This framework was based on PHP and it's called Laravel. The web portal was delivered on this new platform with both existing and enhanced functionality as specified in the scope. Future improvements to this portal have been captured so that the client can maintain a continuity for the new team working on this project. A robust REST API and its associated documentation was also delivered So mobile apps and third-party software can interact with the portal and the data store. Both the data store and the model for observations were refactored to provide a framework that is extensible. The documentation was significantly improved for all the components as part of this project, and clients will also provide assistance with hosting, assessment of external projects like the iNaturalist website, and logo production, which had not been part of the scoping initially. So what was produced? So let's start with Web Portal. The Web Portal delivered was the interactive website called Pollinator Watch, which was developed to assist farmers and others involved in growing of horticultural crops, and also to compile data for researchers to better understand the relationships between crop species and pollinator insects. There was an extensible admin module that was added that can be used by non-technical users without much difficulty. On the data store side, a SQL-based persistent data storage of website and observation details were encapsulated in a model. These models were represented in the MVC framework using an ORM called Eloquent. Map integrations to the data model were also delivered, including a visual representation of the location observations displayed on a map via Google Maps API. And finally, the API was a REST-based API with authenticated access that allows mobile applications and third-party services to exchange data and also access functionality that included the online documentation. So let's start by demo, and I'll hand it over to Thomas to demo the portal side of things. Thanks, Thomas.
Thanks, Raj. And now I'll begin a demonstration of the web portal, starting with the public side and finishing up with the user authenticated areas. This is the home page of the website. It's your landing page when you would first access the site, and it provides an at-a-glance of the project, basically what's involved in the project, what the data is used for, and links to the privacy statements. You can see we followed a consistent minimalist kind of style with the row-based inverse color scheme. This is a requirement from the client. We have our nice little stub articles here with a button to take you through to the full information as required. Okay, in the CSS and scripting, we've made use of JavaScript and Bootstrap just to have these nicely styled buttons, this consistent nav bar to follow you through your scrolling to make navigation a lot easier. We also were involved in the development of these logos to maintain a branding and style throughout the website. Moving on to the observations page, your focus is immediately drawn to the two elements in the midsection of this page. On the left-hand side, we see a tabular view of the recorded observations with the base field species guess, which would be the user inputted guess of what they believe the pollinator that they've seen is, the date this observation was recorded, the location recorded, and accessing through the data model the user which submitted this data. On the right hand side of this midsection, you see the same data, however it's viewed within a zoomable scrollable map. And it's worth noting that this data on both sides is being dynamically retrieved or on page load from the data store. So any additional information or observations that are made while you're using the site will be immediately viewable the next time you visit this page. So for example, if someone uploads an observation while I'm on this page, if I click away and come back or refresh, that new observation will be available. As you may have inferred, given the species guess and the users, we're only viewing test sample data here. However, this is representative of how real submissions would appear. On the map element, each observation is denoted via a marker. These markers are interactive, and upon clicking them, they will load additional information about the observation. Try and find a better one. The ability to scroll around this map and search based on where you are also meets the requirement of the client for a user to be able to view the observations made within a specific geographical location. Moving on to the download data page, we've just provided a button on this page to fulfill the requirement of a batch download. So if we click on this button, it'll generate an export CSV, and this CSV is just a flat table of all the data that has been uploaded to the observations available for review. And if we expand this out, we can see that data has been pulled in. Moving on to registration. So if we're to register a new user, let's, for example, create a new user with the email address test at, in this case, a non-existent domain, hopefully. Pop that in the right area. We'll just call that my test user. We haven't forced validation at this point because this is a test environment. When this moves to a production environment, you would of course require validation before a user becomes enabled on your website. Okay, upon registration, we are now logged in. We come to the dashboard page. And as you can see, there's a message here saying we haven't made any observations yet. If we had, we would have them displayed here. But we also get the ability now to upload an observation of a photo that we may have taken in the field, not had 3G or not had data at that location. And we've come back to our computer and we're going to upload it at this point. So we'll create a new observation. We'll just call this my test ob. Okay, I'm just going to choose a file I prepared earlier. Okay, and from our selection, we'll keep it consistent. How about we pop it about there, not too far from Armidale, and then we'll submit that. So immediately we notice that our dashboard has changed. The observation button is now a little bit less obtrusive, and we have a recording of our observations, the name of what we called our observation, which is the species, and our coordinates. Now if we would then go to the observations page, we would see this user that we've just created, the species guess we put in there, the location that we put on that, and if we click on it, the image that we've uploaded. Okay, as with any authenticated web service, we've provided the ability to log out. Again, clicking log out logs the user out. Okay, that concludes the demonstration of the web portal side, or the public and user interaction of the web portal side. I'm going to hand over to Raj now, who'll do a demonstration of the API.
Hi, I'll be giving you a demonstration for the Pollinator API platform. So let's start by looking at the documentation. You'll notice up at the top, it shows you the base URL where the API endpoints are available. Now this documentation is automatically loaded when you start the Laravel servers. So as soon as it's deployed in production, the documentation is available at API/documentation. The first thing you got to look at is the schemes. So at the moment, we only support SSL-based access to the API, so hence HTTPS is available here. The functionality is divided into two lots. One's observations, which relates to being able to upload observations from the mobile app onto the web portal. And the other one relates to authentication, which is register, login, use a social authentication mechanism, refresh, logout. And to be able to make observations, you will require authentication to the web portal. Now, if you open one of these, you'll notice that it gives you the detail for each one of these calls. So it talks about the method being used, which is post. That's the endpoint /register, describes what it is. So this one, for example, registers a user on the Pollinator platform and tells us a little bit more information about this. Can be done by any user or any app. Gives you the parameter and the parameters that need to be sent with the request. So in this case, it's name, email, and password. You also have to set the content type to application JSON, and the expectation is that you would get an 200 OK response with a token, which is a JWT based token, that allows you to then access things like posting an observation or retrieving an observation. Now, you could also try it out. So when you click try it out, it'll show you an example value, and you can use that to execute. Now, in this case, it's giving you a bad request because that user probably has already been created. So I'm just going to change that a little bit and try again. And so you'll see now that it's gone in real time, made that request, and here's a curl version of that request. And you see there's a 200 with the response body here, the token. And those are your response headers coming back. Now, this applies to every single other endpoint. So each describes what it can do. And here's, you look at refresh, for example, and log out. Now, the most important one is posting observations. So you'll notice that it does require the authentication token to be sent as a header, along with the other parameters, things like the pollinator name and the images, and the lat long. And once you do that, it will log that observation into the web portal, which can be viewed through the web portal. So that's the demo for the API that's been built for this. So the next section I want to talk to you about is project closure and handover. And in this section, I'll be talking to you about the lessons we learned during the project, and also the handover activities that we're carrying out, so that the project can seamlessly be transitioned to the new team. So let's start with lessons learned. I think the rebuild versus refactor was a big decision for us. And I think one of the lessons learned was that it's a critical, non-trivial solution to some problems. We could have easily refactored the existing project and its assets, but we felt that rebuilding it would provide for a better solution that could scale in the future, and also pay out a lot of the technical debt that's been accumulated with the previous effort. I think also addressing the continuity of project team, that can play a major part in avoiding scope creeps. The fact that there were two teams, one after the other, working on the project has meant that different perspectives and ideas are being brought to the table with the client, and this can inevitably lead to scope creeps. It would have been much better to align and sync milestones for the independent components early in the project so as to deliver a robust solution. What I mean by that is that I think the app team and ourselves could have aligned joint milestones, which would have required us to work together to achieve those milestones. The fact that we had independent milestones meant that we did not really have to test integration between the components till the very end. Another big lesson that we learned was that deciding on a methodology has a lot to do with the nature of the teams. The team and the client were remote, and that had a big impact. So although it was helpful to have a waterfall model to help us think through the big chunks of work that needed to be done, the sequence of it was more carried out in an agile manner. And I think that played a critical part in some of the issues that we faced. And lastly, identifying a consistent internal communication and sharing mechanism is a key to ensuring everybody stays on track, especially dealing with remote teams and remote clients. So handover. So the handover will consist of the source code, artifacts, and associated documentation, which we're starting to finalize now. The handover documentation will also be available on the wiki in the source repository. This will help the team get up and going very quickly and continue the project. We've had the final client meeting and sent the emails for final comments and review on the project delivery. The test site will be kept alive till the transition is complete, This will allow the new team to get accustomed to what has already been built. We will continue to provide ad hoc support. Individual members from this team will be available for any questions that there may be from the new team, and the client feedback has been requested. So that's really all the activities that we're working through as part of the handover. Thank you for your attention, and hope this presentation has been useful.